or that global warming doesn't have the economic impact that people think it does. So doing cost benefit analysis requires us to connect things that we have not, you and I have not connected. Right? So we have to connect our estimate that we came up with, the 0.6 of a percentage point for every temperature increase Celsius, right? We have to say we got that and it makes sense and we're there. Then we have to say RGGI reduces CO2 emissions. But we have to say that that reduction in emissions is going to lead to a reduction in warming. And that warming that reduction in warming is going to work. Right? If in the effectiveness side of this, what we talked about in sessions 4 and 5, we had a number of appropriately uncertain outcomes. Right? This is the piece of the puzzle that we contributed. But now the new thing, the additional thing, the cost side is what we didn't estimate. RGGI requires power generators to purchase permits for each ton of CO2 emitted. Those permit costs are passed through to the electricity consumer in the form of higher prices. The total economic cost of the policy includes those price increases. It includes administrative costs of running the program. It includes the competitiveness effects on the industry. And because those firms that are there in those RGGI areas versus those firms in the non-RGGI states, they're going to be treated differently. And then we have distributional consequences for specifically lower income households because they're going to spend a higher share of their income on electricity. We have done none of that. And without the cost side, we cannot complete a cost benefit analysis. So that's basically what that is. So the thing that the thing you and I have provided the policymakers over the course of the last 6 sessions is the benefit side and the effectiveness side. Now, as far as the cost side is concerned, we have to connect these things. So first of all, connecting the benefit to the idea of the damage to the effectiveness. So the conceptual claim is, as I said, I think in the beginning of session 3, is a chain. Right? And this is that chain. It shows how the two results connect within this framework. RGGI causes emissions reductions. Emission reductions contribute to avoided warming. Avoided warming produces GDP growth losses that are estimated in 3, right? So my expectation is that I can avoid those GDP losses if I can prevent the average temperature from increasing. That first link, RGGI to emissions, that's what we estimated. This is day 3. It was meaningful but imperfect confidence, though. I mean, 4 and 5. In days 4 and 5, that's what we did. That first link is modules 4 and 5. We estimated a meaningful but imperfect thing. That second link, right? The second link requires climate science, right? The science people have to get involved in this one. Emissions reductions lead to avoided warming. This requires climate science inputs that are outside of the scope of econometrics. How much does a 6 to 7% reduction in power sector CO2 from 9 US states translate to global temperature change? That depends on atmospheric chemistry, carbon cycle feedbacks, and the integrated assessment modules that climate scientists build. We don't do that. On day 1, somebody asked the question about uh, carbon leakage. You didn't say carbon leakage. I said carbon leakage. It's, well, a state reduces its CO2 emissions, but the state next door does not. If that happens, then pollution is gonna travel. Pollution is not state specific. A state can be adversely affected by the pollution of its next door neighbor. That's what we mean by carbon leakage.